Imagine a place beyond our world, within the vast expanse of the Milky Way where clouds of gas and dust float, unseen by the naked eye. It's like a cosmic nursery, tucked away in the corners of our galaxy. These nebulous entities are called molecular clouds, or if you prefer something a bit more poetic, stellar nurseries. They're composed mostly of hydrogen, the simplest and most abundant element in the universe. But they also contain around a quarter helium and tiny traces of heavier elements. It's a kind of cosmic soup with all the ingredients necessary for the creation of stars. These molecular clouds are the silent giants of the cosmos, drifting through space. They remain unseen, yet they hold within them the potential for celestial life. The process is slow, subtle, almost imperceptible, but within these silent giants, the seeds of stars are sown. In the quiet cosmic ocean, a storm brews. Disturbances ripple through the molecular cloud, fragmenting it. Picture the shock waves from nearby supernovae, like the rumble of a distant thunderstorm, or the collision of different gas clouds like two sea waves crashing into each other. These disturbances, these cosmic ripples, trigger a process that's as common in the universe as it is extraordinary: the birth of a star. As these fragments of the cloud begin to break off, gravity, the cosmic puppeteer, pulls more and more gas and dust together. In the denser parts of the cloud, these cosmic ingredients huddle together, forming a clump we call a solar nebula. As this nebula collapses under its own weight, it spins, flattening into a disk shape. The bulk of the material gathers at the center, setting the stage for a spectacular cosmic event. From chaos, order begins to form. Within the heart of the solar nebula, a fiery protostar is born. This is the stage where the drama of creation really begins to heat up, literally. The central part of the nebula, the stage for our unfolding cosmic drama, sees most of its mass gathering, growing ever hotter and denser. This is the cradle of the protostar, a celestial body not yet hot enough for nuclear fusion, the process that powers stars to begin. The protostar, much like a teenager, isn't quite a star yet, but it's no longer the nebula it once was either. It's in a state of transition, caught between two stages of life. But as the protostar continues to grow, the heat and pressure at its core increase dramatically. This is due to a process known as gravitational contraction, a bit like a cosmic pressure cooker. As gravity pulls more and more matter into the protostar, it causes the core to contract, heating up and increasing the pressure within. The protostar's core is now a furnace, a forge, where the elements of the universe are created. The temperature rises until it eventually reaches a critical point. This is the moment the protostar has been building towards, the ignition of nuclear fusion. The core's intense heat and pressure force hydrogen nuclei to come together, combining to form helium. This reaction releases vast amounts of energy, lighting up the protostar from within. It's a kind of stellar puberty, the moment where the protostar comes of age and begins to shine with its own light. This marks a critical turning point in the life of our future sun. The birth of a star isn't a quiet, peaceful process. It's a fiery, violent event, a celestial explosion of light and energy. The ignition of nuclear fusion transforms the protostar, setting it on a new path. From the protostar's fiery heart, the sun is born. From the chaos of creation, a new star emerges, ready to begin its life in earnest. The sun, our sun, has finally arrived. With the ignition of nuclear fusion, the protostar ascends to the status of a main sequence star. This marks a monumental milestone, akin to a teenager stepping into adulthood. This is the birth of the sun, our very own celestial powerhouse. But the sun's work isn't done yet. It's like the new kid on the block, eager to make its mark. The sun begins to assert its dominance in the neighborhood. It emits a stream of charged particles, the solar wind, along with radiation pressure. This celestial gust and radiant force clear out most of the remaining gas and dust in the surrounding area. It's as if the sun is cleaning up its room, making space for something new, something more structured. And what's left behind? A brand new solar system made up of planets, moons, asteroids, and comets. Each celestial body a unique story of its own, all part of the sun's neighborhood. In the wake of the sun's birth, a new solar system emerges. Our sun, now in its prime, enters a long, stable phase, the main sequence. This is the moment when our sun is in its heyday, just like the prime of our lives, when we are at our most vibrant and energetic. It's the stage where the sun spends about 90% of its life steadily burning hydrogen into helium in its core. This process, known as nuclear fusion, is the sun's life force, the engine that powers its radiance. But life as we know it is full of changes, and that applies to our sun as well. Billions of years from now, the sun will enter its twilight years. Its hydrogen fuel will begin to run out, and this will trigger the next phase of its evolution. The core of the sun will start to shrink, heating up and becoming denser. The rest of the sun will expand, transforming into a red giant. Yes, you heard that right. Our life-giving sun will swell up, becoming so large that it might even engulf the inner planets, including Earth. However, this red giant phase is just a brief moment in the sun's life. It's like the sun's grand farewell before it retires. It will eventually shed its outer layers, creating a beautiful cosmic display known as a planetary nebula. What remains of the sun is its core, now a dense, hot, and glowing white dwarf. It's a fitting end for our sun, which has been the center of our solar system, the source of all life on Earth. Even in its final days, it will continue to shine, albeit faintly, for billions of years before slowly fading into darkness. This is the life cycle of a star, a process that has been happening for billions of years across the universe. It's a journey of transformation from a simple molecular cloud to a glowing protostar, then a radiant main sequence star, and finally, a white dwarf. From a humble molecular cloud to a radiant star, this is the incredible journey of our sun.